Okay, Unit 7, Day 8, we're going to talk about graphing and then shifting logarithmic functions. We've kind of talked about graphing different functions and then how shifts work. We're kind of going to do it all in one day here because as long as we get the parent function down, I think you guys can figure out from there just how the shifts work. So first off, our learning target is I can sketch log functions y equals log base b of x, and then identify the domain, range, and asymptotes. So first off, these guys this is what's considered a logarithmic function when it has y equals and a log. Really just about any base could be on the other side. But as long as it has a log and then x is in the argument, that's a logarithmic function. So as we're doing these, it might be easier, especially we'll do the first column here. We're going to pick our y's first. I think it's a little bit easier than picking the x's. Normally you pick the x's, plug it in, and you find your y. Well, because of the idea that 2 to a power equals x, 2, this base 2 to some power is going to equal x. Well, let's let that power be -3. We're actually plugging into the exponent and then finding the answer. So if you put it in exponential form, it makes a little bit more sense. Since y is the exponent, I'll choose the exponent and then I can figure out what it equals. So 2 to the -3, remember negative means flip it over, so it's actually 1 over 2 to the third, which is 8. This -2, if I plug in -2 in for y, the log to the -2 equals what? So 2 to the -2, that'd be 1 over 2 squared, so 1/4, and so on. So we're going to plug in -1 to the -1, so 1 over 2. 2 to the 0 is 1, 2 to the 1 is 2, 2 to the squared is 4, and then 2 to the third is 8. So let's plot that guy. And again, this is just kind of like the parent function. They're all going to have the same shape, and then just the base will change a little bit about it, but not a ton. So if I were to graph these guys, so if I go 1/8, which is just barely over, down to -8, 1, 2, 3, 4, 5, 6, 7, 8. I'm just barely on the right side here, and then go to 1/4. -2, no, I'm way up here already. 1/4, 1/2, -1, and then 1, 0. Which if the exponent is 0, because this one, it's y is the exponent, so if this was 0, doesn't matter what the base is, it's going to be 1. Anything to 0 power is 1. So no matter what the base is, it's going to go through the point 1, 0. It's kind of like the anchor point, I guess you would call it, of any logarithm. And then 2, 1, 4, 2, and then 8, 3. So it looks sort of like, it should resemble an exponential, only going a different direction. It shoots off to the right like this. Our exponentials came up like this and shot up really fast. Well, this is the inverse function. So if this is an exponential right here, remember, inverse functions flip, they mirror about that y equals 0 diagonal line. So it really looks like an exponential going this way. So it's coming along and it shoots up to the right, but it comes back along and it goes along this asymptote, just like this came along an asymptote and then shot up. So that's what logarithms look like. Okay, they kind of go up along and shoot to the right. And then well, we can do the domain and range real quick. So the domain of this, what I graph here, the domain, what x values can I plug in? Well, you can only get positive answers here. So for this guy, the domain, or I should say you only do positive arguments. So this is from 0 to infinity. 0 is not included, but it does go off to infinity this way. Now the range, this graph goes up and down forever. So -infinity to infinity for the range on that guy. Now if I change the base to a half, not a lot's going to change. So this is going to be a 1/2. Again, the y is the exponent. That's going to equal 8 because the negative exponent flips it over. And then 2 to the third is 8. This is 4, 2. Going a little fast here just so the video is not taking too long here. Down here I have 1/2 to the third power. That's why that's an 8th. 1/2 to the second power is a 4th, and so on. Now if I plot these points, all that's going to happen is, like, When I plug in 1/2, I'm up at 8, so it's going to just come down this way. Basically, is all that's happening. It's coming down. It's going to go through that point. There's 1, 0, and then yeah, let's see. Because I plugged in, it's going to shoot off this way then. But its domain is still all the x's greater than 0, and the range is still going up and down forever. So all that really did, that 1/2, it just made it go this way, kind of like growth versus decay. This is kind of the decay version of a logarithm instead of the growth version of a logarithm. It really doesn't matter either way like that one. But write the graphing form of y equals log base. Let me move this up here. Write the graphing form of this log for any function. And what it is, we're really just taking y equals, and then you got this log base b of, and then x. Well, if there's a number with the x, if I put minus h, that's going to be left or right, opposite of what you think. If I put a plus k on the end, it's up or down. It is what you think. And then if there's a number out front here, if right now we're just going to say a negative out front, so I'll say a negative a is going to reflect about the x-axis. And that also gives it, if you remember, we called it a vertical stretch or a vertical shrink, but I don't plan on changing that number on you, just a negative, what's important. Anyway, and then h, again, is left or right, and it's the opposite of what you would think. K is up or down. It is what you think, okay? So, again, the basic, just the most basic one is this. We always start out with, the parent function. It's going to go through 1, 0, and then from there, what's going to happen. So if we made a t-table in here, again, we're always going to be plugging in for the y first. It's just easier to plug in for the y. If I say xy, and the y I chose here, the y value is 0 on this one. So I'll just plug a 0 in there now. So 3 to what power equals 0? That'd be 1. And then I could say -1, -2. I could go 1, 2. So 3 to the -1 would be 1/3. 3 to the -2 is 1/9. 3 to the first is 3. 3 squared is 9. So that gives me my points to graph here. So 1/9 -2 would be somewhere in here. And this is before the shift. So I'm just doing the log base 3 of x first, and I'll shift them 4 units down. 1/3 -1. 3, 1, and then 9, 2 is off the graph. Now I'll take all of these points, and this says go down 4 units. Now notice the difference between these two. This was not in parentheses. That means it's not with the x, it's on the end. This is with the x, it's in parentheses. That's left and right. Okay, so all these points go down 4. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And there's my logarithm. The domain on this one, state the domain and range. So domain would be from 0 to infinity. 0 is not included because that's an asymptote. The range on this one is from -infinity to infinity, goes up and down forever. And then the asymptote on this one, so the asymptote is going to be x equals 0 because there is no left or right shift. They're all x equals 0 unless you shift it left and right. Okay, so this guy here, I've got my base is 5. Okay, so if my base is 5, I'll plug in y's first. Just always do 0. It's going to be here. It's kind of like that parent function. Again, I'm going to do log base 5 of x first, and then I'll move it 1 to the right. So this says 1 to the right. Okay, so I did 0, -1, -2, 1, 2. Let's see what pops out here. So basically, this is the exponent. So 5 to the 0 is 1. 5 to the first is 5, 5 squared is 25. 5 to the negative 1 means flip it over. Okay, so here are my points I'm gonna plot. Okay, so I'm gonna go 1/25 down, so that's basically I'm as close to the y-axis I can get, and then 1/5, -1, 1, 0, 5. Let's see, 1, 2, 3, 4, 5 up 1, and then 25, 2 is off the graph. Now take all these points 1 unit to the right, which just means this is going to go over to here, this goes over to here, here, and here, and now my asymptote is right here. It moved over also, so my logarithm is coming up along that, and then taking off this way to that one, not the first one, the second dot. Okay, so my domain on this one is from 1 to infinity, not including 1, it never actually touches 1. My range is up and down forever, and then the asymptote is x equals 1. Okay, let's flip this guy over. Okay, just got 2 more to go. So again, I'm gonna do a t-table for this only, and then I will move up 1 and then flip. Okay, so we're gonna move it. We're gonna move it and we're gonna flip it. Actually, we'll flip first. We should always flip things first and then move it up. So always flip first. So first we'll flip, then we'll move it up 1. So if I want to graph log base 4 of x, again, make a t-table. X, y, your base is 4. So let me put this. I'll think 4 to the y. And -2, -1, 0, 1, 2. Probably not going to be able to graph all of these. But I'm taking 4 to the 0 is 1. 4 to the first is 4. 4 squared is 16. 4 to the -1 is 1/4. And then 4 to the -2 is 1/16. And plot those points the best you can. So over 1/16 down to -2, which is along the x-axis. 1/4, -1, 1, 0, 4, 1. 16 and 2 is off the graph. So now I'm going to take all these points, I'm going to flip them over, and then move them up 1 unit. Okay. So if I flip it over, first one, this one doesn't flip. This first one won't flip at all. This one goes up to here. This one goes up to here. This one goes down to there. Okay. So I'm gonna switch to black ink for the ones that I'm actually worried about. So those are my new points, and now I still need to move those up 1. So I'm gonna move this up 1, move this one up 1, up 1, up 1. It's going to come along this asymptote. It's going to shoot off this way, like that. Actually, it can cross over. It's not following asymptotes. It's going to come off this way and go off that way. Boy, that looks like it. I want a continuous curve there. There we go. That looks a little bit better. So it's coming along, shooting off. So domain, since it didn't move left or right, is still 0 to infinity. Range on this guy, -infinity to infinity. And then the asymptote on this one is still x equals 0. We did some flipping and some moving up and down, but that didn't change the asymptote at all. Okay, this guy, I'm going to use this as a parent function, and then I'll go 2 left, 2 down. So 2 left, 2 down after I'm done with that. So if I'm using 3 as my base, so think 3 to the y, so -2, -1, 0, 1, 2. 3 to the 0 is 1, 3 to the first is 3, 3 squared is 9. 1/3, 1/9. Plot those points. Okay, so 1/9, -2, 1/3, -1, 1, 0, and then 3, 1, 9, 2 is off the graph. I'll take all these points, I'm going to go left 2, down 2. So left 2, down 2. Now when I went left 2, this is my new asymptote. And then left, let's see, left 2, down 2. Left 2, down 2. And then left 2, down 2. Connect that right now before I forget. So it's coming up along, goes this way, and then goes that way. Okay, so domain is going to be -2 to infinity, because it starts at -2 here going to the right. range is still negative infinity to infinity. If you notice, that's always going to be the answer. And then the asymptote is x equals -2. So hopefully this wasn't too much, wasn't too fast, but yeah. So that's your parent function, and shift it up, down, left, and right.